Assalamualaikum warahmatullahi wabarakatuh. Alhamdulillahi wahdah, wassalatu wassalamu ala rasulillah, amma ba'du. Hello there, welcome back with Tim. In this serial, we will talk about fluids. Fluids are substances that have the ability to flow, including both gases and liquids. The most common example of a gas is air, which moves through the atmosphere and is experienced as wind. Liquids such as water are also familiar in everyday life, and their flow is widely utilized for various purposes, including irrigation systems, hydroelectric power generation, and even recreational activities like river rafting. One of the key properties that influences the behavior of fluids is mass density. Mass density is defined as the mass contained in a unit volume and is commonly represented by the Greek letter ρ. The formula for mass density is shown below. The symbol ρ represents mass density, where m denotes the mass of the substance and v represents its volume. The unit of mass density in the International System of Units is kilograms per cubic meter. Equal volumes of different materials generally contain a different amount of mass. Therefore, density depends on the intrinsic properties of the material, as illustrated in the table on the right. Gases have the lowest densities because their molecules are widely spaced, resulting in a large proportion of empty space. In contrast, the molecules of liquids and solids are much more closely packed, which leads to higher densities. The densities of gases are highly sensitive to variation in temperature and pressure. Density is defined in terms of the mass of a substance rather than its weight. When weight is required, it can be determined using the mass density, the volume of the substance, and the acceleration due to gravity, as shown in example 1.
Example 1. Blood as a fraction of body weight. A man with a body mass of 70 kilograms contains approximately 5.2 times 10 power minus 3 cubic meter of blood. A. Determine the weight of the blood. B. Express this weight as a percentage of the man's total body weight.
From the previous table, the density of blood is 1060 kg per cubic meter. Using this value and the given volume, the mass of the blood can be calculated.
A. The weight of the blood is given by the weight is equal to the mass times the acceleration due to gravity. First, the mass of the blood is found using the mass is equal to the density times the volume. Substituting this expression into the weight formula gives the result is 54 Newton. B. The percentage of the body weight contributed by the blood is calculated as percentage is equal of the blood weight divided by the body weight times 100. The total body weight is 686 Newton. Thus, the percentage is 7.87%.
A practical method for comparing the densities of different substances is through the use of specific gravity. The specific gravity of a material is defined as the ratio of its density to the density of a standard reference substance, which is commonly taken of water at 4 degrees Celsius. Mathematically, it can be expressed as because specific gravity is the ratio of two densities, it is a dimensionless quantity and therefore has no units. As an example, diamond has a specific gravity of 3.52, indicating that its density is 3.52 times greater than that of water at 4 degrees Celsius. The following two sections introduce the important concept of pressure. It will be shown that the density of a fluid is one of the key factors that determines the pressure exerted by the fluid. Thank you for watching. See you in the next video. Subhanakallahumma bihamdika. Ashhadu an la ilaha illa anta astaghfiruka wa atubu ilaik. Assalamualaikum warahmatullahi wabarakatuh.